Okay, so this is the session from Marco Cardelli of HCL Software. He's going to talk about IBM Z Workload Scheduler, its past, its present, and its future. So this is session 9H. For feedback, please use the QR code or click on it from the agenda. Okay, everybody is muted, so I will remove the mutation. No, that's not the right word. I will remove the mute or allow you to unmute yourself at the end. But if you have any questions along the way, please place them in the chat and I will interrupt Marco to ask them. Okay, thank you, everyone. We will start. Marco, over to you.
Okay, thank you, Anna. So welcome to my session about IBM Z Workload Scheduler. I will talk to you about the most recent feature, what we are doing currently, and what we plan to do in the next months. So let's start with a short description of the market evolution around automation. So just to introduce also our strategy, there is a constant need for automation that is increasing, obviously with the objective of increasing and improving productivity, efficiency, and accuracy for all organizations. So also the digital transformation is a trend that is very important and is pushing customers to move some of their application, part of them in cloud native environments. So this is something important to take into account even for mainframe customers, because they certainly have somewhere in their organization this kind of applications. Also, all these trends combined create a strong need for orchestration of automations. So a tool, an automation tool that is able to orchestrate all kinds of different applications and provide the same control, governance, and compliance for these different automation silos. So this is the introduction to our strategy. We provide a way with our workload automation suite of products that include different engines. So we can have the distributed engine that is not part of today's presentation, but we have also the mainframe engine in this picture. It's a suite of orchestration that can run either on mainframe, at least the server can run on mainframe or distributed, and then there are agents that can be installed basically everywhere on any kind of platform. This especially because all the distributed components can be also available in a containerized version of them. So they can be deployed on container on any Kubernetes or container platform. So what are the three strong points of our solution? We have a single point of control for the end-to-end orchestration of all the jobs and applications that we can orchestrate. And we provide control business views, especially through our dynamic workload console, our web user interface. Then we have the automation hub, where we provide an ecosystem of integrations that is free of charge for our customers. And then in particular, also mainframe customers can use if they have an end-to-end solution, so with our decentric agents. I will talk more about that. And then we have an important part of our strategies that is providing compliance and also workload prediction. So the possibility to monitor the SLA compliance of your workloads. I will just remember that we have a sub-certified solution, and also that IBM Workload Automation has been appointed as value leader from EMA report. EMA is an important analyst of this workload automation sector market segment. And the latest report was delivered in 2023, and IBM is certainly a value leader solution, one of the top solutions on the market for this market. So our strategy is not only, I will talk more about specifically the mainframe strategy, but in general, with our solution, with our suite of products, we want to remove any island of automation in our customers' organizations. We can orchestrate calendar-based and event-driven tasks. We use AI-empowered feature. I will talk more about that in the next slides. We provide self-service automation for enhanced user experience, and we provide the possibility to manage all kinds of workloads in hybrid environments, so on premises, on cloud, on mainframe, on Kubernetes application, all kinds of that. And that is specifically because of the automation hub integrations that we provide. We can automate all kinds of processes, either automate IT processes or business processes. And that's always what customers have been doing with our products. Now, let's dig more into the mainframe part. The modern mainframe is what allows you to still work with the usual characteristics of the mainframe, so keeping control and transparency on your mission-critical data and applications. And I would say also security, because you know that mainframe is probably the most secure platform of any. But with our solution, you can also connect your business critical processes with other workloads, wherever they are. So it's very important in our strategy to connect the Z processes with other applications, in particular cloud-native applications. So the modern mainframe goes a lot through the modernization of the interfaces, providing a web user interface that don't need for people that need to work with the product and don't have the legacy ISPF skills. They can use the web user interface. We provide the REST APIs, new programmatic interfaces that are easier to use than the legacy applications still available. You can still, code to our programmatic interface with COBOL or assembler, but probably with new skills available, REST APIs, it's easier. We have the integrations that allow you to orchestrate any kind of application directly, just defining a job in our user interface. You can do DevOps with our solution, exporting, importing definitions in text format. You can even use containers on mainframe or containers, because there is a ZCX extension that you can enable on the mainframe, and all our workload automation containers can be deployed there. For example, the dynamic workload console, you can decide to install it on a Unix box, but you can install it even on IzWS with the prerequisite of WebSphere and DB2. But you can even, and Liberty, Liberty, not WebSphere, so Liberty and DB2. But you can also decide to run the dynamic workflow console in its container directly on the OS if you use the DCX extension. So you have multiple options, even to install distributed components on the OS. We have the integration with Zoe. Zoe is an open source tool that is supported by IBM. It provides an access cloud-like to mainframe services. Here we are integrated to provide the APIs and command line. If you're using one of the suites, System Z suites that include IzWS, you can have also out of the box ZChatOps, a chatbot developed by IBM that can simply integrate with a chat different mainframe products, including IzWS, to have to support a collaborative approach to the mainframe. Also, you can use our self-services interfaces for business users. So you have lots of new modern interfaces where that we provide for our product. So here you have a glance of all the integrations that we provide to work with the product. Here is a picture including the Service Management Unite. That is one of those components available with the with the Z suite, the automation suite. But we provide the dynamic workflow console as a standard component free of charge of our IBM Z workload scheduler engine. You can have controller and trackers. You can have Z-centric agents connected. You can use REST APIs that are available from the dynamic work console server. You can use the self-service catalog on mobile devices for business user to submit and track job streams. You can use GChatOps for a collaborative problem resolution. You can integrate with Zoe and its command line. You have the AI Data Advisor. There is a component, internal component of IzWS. Deployed on container. You can use observability data from the Z engine and have Instana observe it, or use the Z common data provider to move our log information to Splunk or Elasticsearch. And you have all the integrations of the Automation Hub. So you can see that we provide a very rich ecosystem of integrations for our mainframe solution. So let's talk a little bit more about the integrations and hybrid cloud integrations. So the Automation Hub, you can find more than 100 out-of-the-box integrations. For this, you just need to install the dynamic workflow console that is free of charge, and have Z-centric agents that run on distributed platform or even on Z Linux to run these applications. So all these integrations will be executed by Z-centric agents. We provide a number of integrations for many different automation domains. File transfer, relational databases, RPA. You can automate RPA bots with our integrations. You can automate a lot of different cloud services. We provide many integrations for the three main hyperscalers, AWS, Azure, and Google, and a simple way to execute Kubernetes batch jobs. We provide big data integrations like Snowflake, Informatica, DataStage, and so on. We provide integrations to provision virtual machines on the hyperscalers, for IT service management like Jira, Ansible, ServiceNow, ERP integrations with a lot of different business applications like SAP, Oracle e-Business, PeopleSoft, and so on. So there is a very rich ecosystem of integrations out of the box. You don't need to be charged for anything. It's all included in the product license. This is around observability. This is a little more for the distributed components, for the distributed engine, but it's also available for Z. And you can observe some of this data using one of the multiple observability tools available, in particular for IBM, we provide IBM Instana dashboards. This is instead the solution to provide our logs to analytic platforms like Splunk or Elasticsearch. You can do that through the Z Common Data Provider integration. I know that this component is also provided out of the box for customers who install the system, the automation suite. So the way we interact with the common data provider is that we write you can configure our controller to write data to a log file that then is forwarded from the Z Common Data Provider to Elasticsearch or Splunk analytics engine. Also, an important picture I want to show is around the way to provide alerts from our product. We have the standard legacy way to provide alerts that can be intercepted in the system log as WTOs from NetViews or other similar products. But we have also modern ways to provide alerts. We provide an integration with ServiceNow. You can open a ticket to ServiceNow every time there is an alert. Or obviously you can configure which alerts you want to open tickets for. You can send alerts to the chat bot, the chat ops. You can send an email to any user you wish. So you have multiple ways to use our alerts. From obviously we have dashboards on the dynamic workflow console that also can provide alerts. So you have multiple ways to work with our alerts and customize your own solution, from legacy through NetView and other specific mainframe solution to modern solution like ServiceNow, tickets on ServiceNow or chatbot. Let's now talk about the evolution we are doing with AI for IzWS. So this is starting from the basic. We have predictive scheduling. We have predictive scheduling in our product since a number of years through what is called workload service assurance, or also well known as critical path management. You can define critical jobs and with as your critical endpoints. So you can define your critical endpoints in the workload as critical jobs, and define as their deadline your SLAs. In this way, you can monitor SLAs and manage them with specific views available. You can have automatic prediction of job risk level for all your critical jobs based on embedded analytics. So it's something that is automatically created during the planning phase of the product, and then kept up to date during the execution of the workload. Within these functionalities, there is also a way to promote the execution of late jobs to a higher service class. So an integration with workload manager. This is very powerful. Some customers use it very successfully. So you can define that the jobs that are late on the critical path of your critical jobs, if they are late, they can be promoted to a higher service class that you define, so that they can have their execution can be accelerated, and you can even recover the delay and avoid to miss your deadline. You can also use the what if simulation dashboards, the Gantt view, to visualize impacts on critical paths. So, for example, you can do scenarios like, I know that a job will start later than expected for a number of reasons, or the workstation will be unavailable. What's the impact on batch execution? Then I can simulate actions and check what's the impact of those actions on the workload execution. So this is something we had in our product for a number of years. Then we delivered with 10.1 a new feature that is based on AI to perform anomaly detection and analysis of the workload execution. It's called AI Data Advisor, and it's based on machine learning and AI technology. So how this works is that this component receives data from the engine in open metric format, kind of standard format. So this is live data that is received while the execution of the job occurs. And based on this analysis of data received from the engine and historical data collected, this component is able to have a proactive approach that minimizes your operational risk. So it can detect an anomaly in the execution of the workload in comparison to a similar day. So it can help by detecting that, for example, you have too many jobs in queue waiting for execution in comparison to a normal day. And that could be something you expect because you know that that day is going to happen something particular, or it could be a symptom of a problem. So in that case, that proactive alert would allow you to manage the issue before it becomes a problem. So we provide some possibility to analyze the root cause of the problem with some specific UI that this component provides. So this can be launched in context from the dynamic workflow console. Basically, in this way, your operators can be alerted when there is a potential problem, when there is an anomaly detected. Use the dynamic workflow console and the AI Data Advisor UI to analyze the possible issue and perform a root cause resolution and prevent this to be a real problem, or at least limit the impact of this. This new component is free of charge as well, so part of the standard license, and it's deployed on container. So you can install it either on a distributed platform, on Linux, or on IzWS if you use ZCX. Why we think that this tool is useful? It's because we want to empower operators to understand how the execution is going, even without being power operators. So very experienced operators that can easily understand how the workload is doing. This should help any operator to become a power operator. Their experience of power operators is achieved through the usage of data analysis and machine learning applied to historical data. Okay. Let me move to next topic concerning the usage of AI. So this is very important news. We are working at a project called AI Infused Scheduling, and we are cooperating with the IBM System Z on this. As a matter of fact, IBM ZOS 3.1 that was actually GA'd, I need to update this slide, was actually GA'd in September 23, marks a new era in the operating system intelligence. We have an AI new framework available for mainframe users that runs on ZOS. It's an ad hoc new engine built for ZOS. It's not something ported from another platform. So this AI engine will enable new possibilities for the execution of the workload. What we called, the project is called AI Infused Scheduling. So first of all, the timeline. We will have, we had a phase one, NSP, small program enhancement, PTF that was delivered in the 4th Q of 2023, last December. And I will talk more about that. And then we have a phase two that is expected on top of the new release 10.2 in 2025. And this is also something that is related to the delivery of the ZOS next version. So the first is a first step in the usage of this AI infused scheduling in a very specific scenario. Phase two is much more, it's supposed to have a wider impact on the execution, on the optimization of the execution of the workload. I will talk more about the phase two. Phase one is early submission to JES of jobs with a not expired time dependencies, based on the usage of a symbol, JES symbol that is called sysHoldUntil. So basically, you can configure the controller so that jobs that have all dependencies resolved apart from the time dependency, they can be submitted to JES in advance, and we can leave to JES the responsibility to start the job after the time dependency is resolved. Why this can be useful? Because JES can prepare its resources in advance to execute that job. Actually, let me talk about this in detail. The effect of hold theory. This is related also, to the enhancement performed by WLM in ZOS 3.1 to what they call the managed batch initiators smarter scheduling. This smarter job scheduling approach is based on the fact that we can communicate job insights in advance. And so that WLM is able to adjust and project initiators proactively. Jobs can be submitted in advance with this hold until option, And the system in this way is able to get insights about the upcoming job submissions. So if three-queue jobs count as batch queue delays, WIM policy and resource adjustment will start initiators in advance before the jobs are released. So in this way, basically, the system prepares to execute the jobs before they are started. Actually, this is a way to have initiators available just in time. So this is what you can achieve with this already available PTF of 10.1 of IzWS. Obviously, if you're using IzWS 3.1, you need to be also on that level of operating system. Let's now instead take a look at what kind of problems we want to resolve with AI, with the second phase of AI-infused scheduling. In general, this is the questions that we want, that the operating system, JS, and WLM want to answer. What is about optimizing the batch scheduling? So what jobs should be run next? What system should a job run on? How can we balance the sysplex resources to optimize the execution of the workload? Can the system, in the systems that belong to the sysplex, anticipate what is coming and be prepared for it? So to do that, there's a need of collection of information concerning historical data of execution of the jobs. Obviously, they need to use live data such as resource usage. In the profiles related to the profiles of the jobs that are being submitted. Basically, there is need to build a profile of a job that is periodically submitted, and the system can be prepared to its execution. So, and also all the information related to the job, how critical is the job for the execution? Does it have a deadline? What is it? So all these are problems that we want to face together with the system Z, with the operating system, to optimize the execution of the batch scheduling. Why is so important the cooperation between the job scheduler and the operating system? Because the job scheduler knows the identity of jobs. So it's possible to correlate in this way multiple execution of the same job and allow to store information about previous runs of a job, and allow the system to know which job is going to be submitted, because if the system knows the job identity, then knows already what to expect. There are 2 points of interactions, basically a job termination that allows to collect information about how many resources the job has been using. At a job submission, we can identify the job that is going to be submitted, so allowing the system to know what to expect. So this is a picture of what we are working on for the 2025 with the operating system. The job scheduler 2 will be responsible to identify the job, so that because we know where the job is defined when it's again the same job submitted to the system. So that will be identified through a token that will be passed when we submit the job to JS. At that point, the JS can be configured to collect statistics about the job execution that will be related together with the job token. So this will allow the system to organize itself to optimize the execution of the work of the jobs, knowing in advance what resources they need. I like to talk about this because I think this is a very cool feature for the future, something that will be very important for the evolution of the mainframe.
Marco?
Now, yes?
There was a question about hold until.
Okay.
From Des. He wants to know what happens if after IzWS has early submitted the job, they decide they want to hold it or cancel it. And what status will it show in the panels? Will it just show as S, or can we distinguish an early time-dependent submission from other submissions?
Okay, I can partially respond, then I can provide more information later if you ask me with an email. But basically, the point is that when the job is submitted, it goes into S state, so it's submitted. It's started from the point of view of the controller, but it has a substate identifying that the job is submitted but still not in execution. So there's possibility to understand that the job is queued. I think we also introduce a substate specific for this condition, so submitted with hold until, but I need to double check that. So this is what happens. We give control to Jess, and then obviously the condition is that the job should be not submitted before that time that is defined by the user, but obviously can be submitted later than that time. So it's up to Jess to submit it as soon as possible, but there is no problem if it's submitted a little later. I hope I answered the question.
So if they, after it's been submitted, but not running yet, they want to cancel the job, can they do that within IzWS, or will they have to do it within Jez?
They have to do it in Jez.
Yeah.
It's
Okay.
because it's already in the Jez initiator queue.
Yeah.
That's it. Okay, so let me proceed with the latest announcement and the roadmap part of the presentation. So first of all, a quick recap of the latest deliveries on top of 10.1. We had the 3 set of SPEs, so small program enhancement delivered through PTFs. So the first 2 included the support for the renewed self-service catalog. This is something that is implemented in the UI, but also it let's say prereqs the installation of this PTF, because the self-service catalog, so the feature where customers can associate job stream definition to a service that can be submitted from the self-service catalog interface, used to be the definition of that used to be local to the dynamic workflow console. Now it's part of the database, so you can flag any job stream to be a service, and that's why you require there is an SPE that supports this enhancement. The support decided to support the self-queuing for TCP or PTS TCP/IP communication. Before there was a different kind of security, only supported for TCP or PTS, and self-queuing was only supported for HTTP communication. Now it's also supported for TCP/IP standard communication. And we also support TLS version 1.3. Then another point was some integrations of available on the Automation Hub that provide that allow to define as a job that will open a ticket in ServiceNow or Jira. So basically to implement an approval flow in your job stream. Another integration with ServiceNow that we provided is instead to open a ticket automatically when there is an incident happening in IzWS. So the one that I showed before with alerts. An alert can cause, if you configure this feature, to open a ticket to ServiceNow. Then we delivered also the possibility to deploy this agent on Kubernetes, and enhance the Kubernetes job plugin, as well as allow dynamic JCL library allocation for job submission. So you can define through a user field specifically documented. You can decide that a job, instead of using necessarily a library that is allocated within the job library concatenation, you can also use an external file, a external dataset on the system that will be dynamically allocated for reading the JCL. So this is some kind of scenario that should be used for specific reasons, like you need to define a new job library, to use a new job library, but you don't want to restart the controller and update the job concatenation, for example, things like that. You can do it right now. Next is what we delivered in the latest December. I already spoken about the Sysold Until enhancement. We also developed an integration with IBM the JCL expert, sorry about that. And this is a new tool that IBM is recently delivered to basically verify the JCLs. So it's a tool in that area. We integrated with that so that when you modify a JCL from an operation that is in error, you can invoke JCL expert to verify the JCL after you edit it. So before saving it, and so you can do validation before submitting the job. Then another very important announcement, in my opinion, user exits. We have a lot of them, and until this delivery, it was necessary to use assembler code to write assembler code to use these exits. Now we allow customers to use Metal C, which is probably easier to use than assembler, where skills are no more available in assembler. So we developed a workbench to develop user exits in IBM Metal C. Some of we also delivered some samples of these exits, a subset of them, and we will complete them in the next future. So all samples will be available also for this in this new workbench to develop exits in Metal C. And a few customer ideas. I always remember to our customers that we deliver their requirement, their request specifically. Every time there is any delivery, we implement a few of them. So let's look at the roadmap. What is very important, I have around 10 minutes left with the future. We are working to a new release, 10.2 release for IzWS. And our plan is to deliver it this year in December 24. We have 3 main items and one that is in extended content. And the the three main will be, I will show a slide for each of them. It's extending the matching criteria for cross dependencies. Then we are doing the plan mirroring for dynamic workload console, and supporting through this the new monitoring that was already delivered with distributed 10.2 in 2023. So the new monitoring in the dynamic workload console currently is not supported for Z. So you still need to use the old monitoring, but with 10.2, it will be available also for Z customers. And then we are working to support data exchange already available on the distributed platform, also for Z-centric jobs. But this is an extended content, so it's not committed for 10.2. So a few more details. This is the JCL expert integration. I already explained a little bit. You have only here a couple of screenshots from the dynamic workload console and how it works. There's a button you can click for JCL check if you configure the integration with JCL expert. This is just the first step. Probably you will see more of this integration in the future. And this is the user exit workbench, where you can, there's a new panel where you display the main menu. You can use this specific workbench to code your user exits. It's you can configure it to use also to compile the code and make it available as an object. There are samples available on GitHub, and also we want to allow to share samples with other users. So these are the 4 committed contents for 10.2. Let's go one by one. So what is the mirroring and the federated mirroring? So the objective is to have a subset of the plan data that is currently only in the visual files that can be replicated in one of the supported databases, so relational databases. So why is that? It's going to be also named federated mirroring, as it will include also distributed data, plan data, if you have also IBM workload scheduler installed in your organization. So if you have both engines, you can support in this way multiple engine queries. So the plan objects replicated on the database will be job streams, jobs, and workstation. And this DB data will be populated during the CP current plan creation phase and updated during the plan execution. Obviously, the idea is that all the queries on these objects will be executed directly on the database rather than sent over to the controller. And this is going to improve the performance and also, let's say, improve the performance of the controller, not only of the UI, because all these queries will not be queued to access the visual files. So all these queries will go directly to the relational database and will not cause any performance issue on the controller. So it's a very important enhancement. So the queries will be much faster. If anybody complains currently there is a bottleneck in the controller, in the execution of this query, well, this will cause a lot of improvement. We will also provide a new type of REST APIs that will be called version 2 APIs. to support the new orchestration monitoring. Also, obviously, will be available for API calls. And these are already available for 10.2 and will be available for distributed 10.2 and will be available also with 10.2 for Z. So another very important thing is that we have a long list of requirements to provide complex filters on the dynamic workflow console. And these kind of queries are too heavy to be performed directly by the controller because we need to basically scan the whole plan to satisfy those queries, putting data in, and not only in order, very complex filters. So instead, this will be something easy to do on a relational database. So we will be able in the future to implement complex filters also for the mainframe on the dynamic workflow console. Last, a glance at the architecture. The communication from the Z controller to the federated mirroring component will use WebSockets. The authentication will be performed through JWT token, and all the security will be executed on the mainframe through your SAF product. The federated mirroring component will be installable on premises or deployed in a container. Now, a glance at the enhancement we want to provide on cross-dependencies. Cross-dependencies are capability to interconnect multiple engines, dependencies between jobs that are running in different engines that can be all Z or even Z and distributed. Right now, the requirements are to extend the matching criteria. So right now, for cross dependencies, we support only the nearest preceding input arrival time, but this is not enough for customers that have multiple Z engine. So they required to implement also the other three that are available for standard dependencies. And then also to show the origin side operation occurrence, there is a cross-dependency relation from a shadow job. So more information on all the interfaces to better detect shadow jobs and all the information related. Then we are also planning to implement a few requirements from customer as usual. Here there's a list. One is related to the decentric agent, the possibility to disable the sub-job user, one user field. I think that on operation user field that we implemented in the past for a specific scenario. So customers want to be able to disable it. Update in COBOL 6 the sample for the legacy programmatic interface. Then also some enhancement of long duration messages. So that's what we have in plan for 10.2, and the plan is to deliver it in December. That would be all for the content of this presentation. I'm not sure if there are other questions I should answer.
Okay, so I have made it possible for you to unmute yourselves if you want to have a conversation. There was a little more on the hold util. From Des, I don't know, Des, if you want to unmute yourself and discuss.
Yeah, thanks everybody. If we've got to go and cancel it in Jez, then it's a palm that we wouldn't be wishing to use, because that would require us to then open up RACF people to go and do things to production batch jobs.
Okay, so you would like to us to implement the command from the controller, basically?
Yeah, absolutely. Please, yeah. I think
Okay.
the facility sounds really interesting, and potentially powerful. But yeah, that would be a blocker for us making benefit of that.
If you want to monitor this requirement, I suggest you to open an idea on the IBM portal. I think this is a reasonable requirement, so we can consider it.
Will do.
Yeah,
Thank
it
you.
would be. I think it would be nice if you can extend the manual hold to something that's been submitted, to send the hold command, maybe to Jez, and then of course the
this is
manual means
another.
let it
Yeah,
go.
it's another possible requirement. That makes sense.
Yeah. So, but I'll leave it to Des to raise the idea.
Okay.
I think you usually ignore mine.
Not true. I ignore I ignored just a few, but we have like 200 requirements, and we can.
Indeed.
I wish we could implement them all, but unfortunately we need to prioritize and also implement new features. So,
yeah.
But I think this makes sense in this new scenario. So. I didn't think of it, and I'm not actually anymore the architect of the product. I'm the product manager, but it makes totally sense now that you ask.
Anybody else have anything they want to discuss with Marco on this session?
Can I just follow up on Hamish's question around if there's a new version of the ZOE IWS extension available? I think we've only got a version 1 available. I think ZOE is now not supporting that version.
You mean ZOE 2 version of
yeah, a 2 or 3. I think ZOE's up to 3.
Okay, I need to verify that. I know we are working to support to extend the support to a new version. I'm not sure if we already delivered that or not. If you want, you can drop me an email and I can reply about that. I don't remember actually this detail, but we are also, if we haven't done it yet, we could certainly plan it for the near future, either with the new release or just after that.
Fabulous, thank you.
Sure.
Anything else, or if you just want to say thanks to Marco for presenting? Yeah, we have one thumbs up.
Okay, thank you all for joining the session and following my presentation.
Thank you, Marco.
Thank you, Anna.